Now, a little word problem here. We're planning an awards banquet for our school. We need to rent tables to seat 180 people. Tables come in two sizes. Small tables seat 6, large tables seat 10. The equation 6x plus 10y equals 180 is our equation. Remember, x is small tables, y is large tables. So we got to graph this. Okay, and we're going to graph this by using intercepts. Okay, so first we're going to find an x-intercept. Just like we did on the last problem, y is going to be equal to 0, so we're going to say 6x plus, instead of 10 times y, we have 0 now, because we're x-intercept, equals 180. 10 times 0 is 0. Those cancel out. 6x equals 180. Divide by 6, divide by 6. So x is equal to 30. That's our x-intercept on our graph. Now our y-intercept, let's squeeze this in here. Y-intercept is where x is equal to 0. So 6 times, not x, but 0, plus 10y is equal to 180. 6 times 0 is 0. 10y equals 180. Divide by 10, do the opposite. We're multiplying, so we're going to divide. Y equals 18. Okay, so we have our two intercepts. X is 30, y is 18. Now let's throw our graph down here. For this problem, it doesn't make sense to have negative tables, negative people, so we're only going to graph our positive quadrant here. Now let's go to our x-axis. Let's count by fives. So 5, 10, 15, 20, 25, 30. Okay, and that's our x-intercept. It's 30. Okay, it crosses our x-axis at 30. Our y-intercept's 18. 5, 10, 15, 20. It's not quite to 20. We got 18. Okay, right, close to 20. And let's connect our dots with a straight line. And there's our graph. So what this graph means, we got to understand what it means. Okay, down here at our x-intercept, that's where we have 30 tables. Now, 30 tables right here, our y is 0. Okay, that means we have no large tables. We only have small tables. Okay, and when we have 30 small tables, that seats 180 people. Now up here at 18, we have 18 large tables and no small tables. Well, 18 large tables also seats 180 people. Now every point on this line is a combination that would seat 180 people. Okay, so what part B is asking, find 4 possible solutions. We're going to pick out points on this line where it gets us to whole numbers. Now, this would be easier with graph paper. Okay, this isn't going to be very exact. But, for example, we could, let's trace over, let's say we're going to go to 10. Okay, 10 right here on our x-axis. That means 10 small tables. Okay, and 10 small tables, and let's go trace it up to our line and over. Okay, let's say, that's about 12. Let's say that's 12 on the y-axis. Remember, y is large tables. So if we have 10 small tables and 12 large tables, that should seat 180 people. Now, again, with graph paper, it's going to be more exact. Okay, but each point on this line is a combination of tables that would work. Okay, so we're going to pick out combinations on this line that would work. So we're going to say one possible combination could be 10 on the x-axis. Again, x is small tables. 10 small tables and 12 large tables. Okay, and we could write it as an ordered pair. 10, 12. Okay, and that's one possible solution. Now we could pick another point on the line. We could say maybe 25 and trace it over to our y, and maybe 25 and 5. Okay, that could be another combination. So that's how we're going to find our possible solutions.